Okay, students, in this video, we're gonna actually complete the engine assembly. So by now, you are expected to have completed all of the different components for the engine, including the piston rod, piston head, the engine block, and the crankshaft. And then what we'll do today is we're gonna actually assemble everything together. Okay, so here you will, of course, use the existing components that we previously created, and we're going to use those to create an assembly. And then we're also going to create joints for each component. So those joints will be different depending on what we need that particular component to be able to do. So if you recall from some of the other videos, we're talking about degrees of freedom and things like that. And then finally, we're going to talk about grounding and testing that assembly. Okay, so we'll go ahead and jump into Fusion. And then what I'll do here is, of course, I have all the different folders for the different weeks. So what I'll go ahead and start doing here is I'm going to first save this file. Remember, anytime you want to start an assembly, you always have to save the file first. That way you have a location to actually send the different components to. Okay, so in this case, I want to call this engine assembly. And for the location, I'm going to make sure I send it to week 4. So there it is. I have the engine assembly. Now, here in my data panel, if you recall, we created the components back in week 3, not in week 4. So you have to look into week 3 to try to find those components. So what we'll do here is we'll first add the engine block. So that way we know that that engine block is set. So we're essentially trying to replicate exactly what happens in real life. Okay, so we start off with the engine block and then we'll start adding the different components to the engine block. Okay, so in this case, I'll go ahead and attach that engine block there. Now I can actually move my engine block here, so I have the 6 degrees of freedom to place it. So I can move it in the X, I can move it in the Y, or I can move it in the Z. And I also have rotations. So I have rotation about Y, rotation about X, and rotation about Z. Okay, now in this case, I want it to stay exactly where it is. I don't want it to go anywhere. So I'm not going to adjust anything. I'm not going to move any of the arrows or circles here. And I'll just go ahead and hit OK. Now, before I do anything else, what I want to do is I want to make sure that this engine stays in place. Okay. So we've talked about this briefly before. So what I want to do is I want to ground this component. So what I'll do is I'll go ahead and select the engine block, right click it, and then select ground. Okay, and what I did by doing that is now I can no longer move. If I click and drag that component, it's no longer going to move. Now if you think about it, this is exactly what happens either when you're assembling an engine in real life, or after it's already been assembled. Once the engine is actually put into the car, they actually ground the engine itself, so it doesn't move, it doesn't go anywhere, and then they start attaching everything else. Now if you ask me, well, the engine's not really grounded in a car. In essence it is. So all it is, it's actually attached to the chassis, of course, with some engine mounts to try to minimize vibration, but itself it's actually grounded. Okay, so it's actually stuck to the chassis of the car. It's not gonna run off anywhere. So that's exactly what we want to do here. Okay, now once I have this engine block, I have to make a decision. So I can either attach the crankshaft, or I can attach piston rods and piston heads. Okay, so let's start off with the crankshaft first. So I'll go ahead and click and drag the crankshaft into the environment. Now what I want to do before I hit OK is I first want to place the crankshaft pretty close to where it should be once it's joined together, but I want to leave a little bit of space. So the way I call this is I want to sort of position that component to where it just wants to fall into place. Okay, that way Fusion doesn't have to make any crazy decisions for us. And in this case, we can see how that crankshaft sort of will just fall into place up into the engine. Okay, so that movement, that position seems good enough for me. I'll go ahead and click OK. Now, before I continue, let's go ahead and join the crankshaft to the engine block. Okay, now to do that, we first need to create a joint. But before I create the joint, let's have a brief discussion as to what the crankshaft needs to do within this assembly. So the crankshaft needs, so this main shaft needs to attach to the engine block in these locations. So this, I guess, half of cylinders type of cutout, that's where the crankshaft actually has to attach to. Now in real life, here you would have some type of bearing or low friction system to allow the crankshaft to freely rotate. So in this case, since we're just sort of doing very simple yet sort of complex designs, we're not going to go into that much detail. Okay, so we're just trying to do simple shapes but still have an adequate enough level of complexity. Now, as you can see, we have multiple of those locations. So we have one location there, and then another one there, and so on and so forth, all along the engine block. So what type of joint do we need? We need a joint that allows free rotation of the crankshaft. So just one rotation. Now it should rotate about the center axis of the shaft here, but it shouldn't be able to rotate in any of the other two directions. Okay, so just that one rotation. Now once the crankshaft is in place, then it should also not be able to slide into any of the three dimensions. Okay, now with that being said, I'm gonna overlook that last part for a second, and then eventually when we finish constraining everything and joining everything, that should take care of itself. Okay, so what I'll do here is I just want to make sure that that crankshaft is able to rotate freely off the engine block. So what I'll do here is I'll go ahead and select the joint. Now it's asking me to select the two components that I want to join together. So let's try out the first one, which is probably what most of you would try, just by looking at the different designs. So most of you will probably be tempted to select that edge and select this edge. Okay. Now, of course, that shows a rigid type of joint. So all we need to do is go into motion here, and then there's different types that we can pick. So in this case, we can try a revolute, which is allowing that free rotation that I want. Now, the issue with this joint is it seems to be working here, but if we take a look at the rear part of the engine block, we have a piece of the shaft of the crankshaft sticking out the back. And if we were to take a look at it from the bottom, you'll see that all the torque sections are not centered within the cylinders. So that being said, in this case, this is not going to work really. I need to have a little bit of an offset here in the front of my crankshaft, down in this direction a little bit. So that type of joint is not going to work for me. So what I'll do is I'll go ahead and hit cancel, and then I'll try something different, and hopefully we get the results we're expecting. So what I'll try next, so remember we selected the edges that should be in contact. Instead, what I'm going to do is I'm going to select the surfaces. So in this case, this round surface should come into contact. And of course here, if you see it highlighted in blue and the other component does not change color, then it's just asking you for a confirmation. So all you have to do is just select the surface again, and then it's gonna confirm that you're actually selecting that. And then in this case, we select the other one as well. As you can see, it sort of fits in, but in this case again, it defaults to rigid. Now I can try Revolute, and that seems to work. The only issue I have with Revolute though is that, as you can see, it's not perfect still, so it's not centered. So instead of doing a revolute, what I'll do is I'll allow this to be a cylindrical type of joint. So this will allow me that free rotation, which is what I want, but it's also going to allow me that free movement up and down that axis. And that's going to be helpful because I can actually shift the crankshaft within the engine block to fit in perfectly centered along the cylinders. Okay. Again, we don't want this movement, but we're gonna take care of that later on in this video. Okay. So at this point, we just created a cylindrical constraint between the, or cylindrical joint between the crankshaft and the engine block. Okay. Now, before I move forward, there's another decision that we have to make here. So we actually have to attach 8 piston rods into this assembly and 8 piston heads into this assembly, and then we have to do 8 separate joints between the piston rod and the piston head, and then the piston head and the cylinders, and then finally the piston rod and the crankshaft. So that seems like a lot of work, okay? And it's not something you would really see in real life. So before they actually position or attach the pistons into the engine block, they actually assemble the piston itself first. So they have a sub-assembly, okay? So that's what I'm gonna do here. So what I'll do is I'll go ahead and start a new design. I'll go ahead and save it because it's gonna be an assembly, so I need to save it first. And I'll go ahead and save this as piston assembly, okay? And of course, this is trying to save to week 4. It's all good, or I can even save that to week 3. Doesn't really matter. Week 3 can work because I can have it right here. So I'll go ahead and do that. So I'll attach it to week 3 and then save it, so it saves that new file there. And then what I'll do here is I'll actually attach 1 piston rod and 1 piston head into this assembly, and then when I save this sub-assembly, then I can just take this sub-assembly and attach 8 of them into the main assembly for the engine. Okay, so that's what I'll go ahead and try. So first I'm going to attach a I guess a piston rod. So I'll add the piston rod there. Now what I want to do here is I want to make it vertical like so, and then I'm gonna move it up a little bit. Now the reason for this is I could have done it the other way around, but I'm trying to position this as close to what it's gonna attach to once I add it to the general assembly. Okay, so if I have it laying down, then when I introduce that into the workspace for the engine assembly, then it's gonna be laying down, so I have to adjust all of them once I add them and when I try to actually place them into their location. So I'm not gonna do that. Instead, like I said, I wanna save some time, so I'll go ahead and move them a little bit, try to place it close to where I want it. As long as we're in the front of the origin this way, and then vertical, then we should be good. I'll go ahead and click OK. And now I'll go ahead and add the piston head. Okay, now the piston head is attached there. So again, I want to place this in such a way that it just wants to fall into place. So here I'm going to do a 90-degree rotation first this way, and then another 90-degree rotation this way, and then I'm just going to shift it up. Okay, and then a little bit to the left maybe, and a little bit further up, and I'll go ahead and hit OK. Now here I have enough space to select the edges or the different parts of the components to join them together. Okay, so what I'll do here is I'll go ahead and start a joint, and I'm gonna select the points of contact between the two. So in this case, I want to make sure that this edge on the piston rod comes into contact with this inside edge of the piston head. Okay, so I'll go ahead and do that. So this edge to this edge, and as you can see, it defaults back to the cylindrical, which is the last type of joint that I used. But if you notice, the piston rod moved to the piston head because I selected the piston rod first. I don't want to do that, so I'll go ahead and cancel it, and I'll try again. This time I'm going to select the piston head first and then the piston rod, because I want the piston head to adjust to the piston rod, because I already placed the piston rod. Okay, now it seems to be working, except I don't want that sliding motion in and out. Okay, so for my motion or the type of joint, I'm going to replace cylindrical with just a revolute, and it seems to be doing that. Now, of course, it shouldn't go past the piston rod, but at this point, I'm not going to worry too much about that. There's ways to actually set the amount that we want, but at this point, I'm not going to worry about that because my assembly, the assembly itself, once I put everything together, it's going to automatically limit those motions or those limit points. Okay, so at this point, that revolute joint works. It's doing exactly what I'm expecting it to do, so I'm going to go ahead and click OK, and I can actually test it out. Now, as you can see here, I sort of screwed up because I didn't ground the piston rod. Okay, now when I move it, it's not showing me that pivot motion because there's nothing to ground. There's nothing grounded that will allow me to actually just move that piston head to pivot, right? So what I'm going to do here is I'm going to Control Z, so it goes back to the original position, and then before I try that again, I'll go ahead and ground the piston rod. So there it is, it's grounded. And now if I move the piston rod, it's grounded, so it's not going to go anywhere, but it's still allowing me that free rotation of the piston head. Okay, so this is good. It's doing what I expected to do. Now what I'm going to do next is I'm going to turn off the icons for the joints here. Now the reason for that is I know that this joint works, so I'm going to turn off the joint there so it's not showing, but it's still going to be attached together by that joint. Okay, the reason for that is I want to have a clean final assembly, and if I have all those joints turned on, then it's going to make it hard for me to do that. Okay, so I'll turn off the joint, but it's still active. It's just hidden away. The joint is doing what it's supposed to, and then I can Control Z a little bit just to place it right where it needs to go, so flat, and again I can turn off the joint, and then all I need to do here is save this file, and I now have a piston assembly that I can use. So I just saved this work from being done 7 more times within the big assembly. Okay, so back to the big assembly, I can just select or click and drag that piston assembly into the environment, and as you can see, it's showing up exactly where I placed that piston rod. Okay, which is good. That's the reason I did that. Okay, now what I'm going to do here is I'm just going to position it in the different locations, and of course I want to try to adjust the angles a little bit just so it makes my life a little bit easier when I put them together. Okay, so there's my first one, and then I just repeat the process for 7 more. Okay, so I move it up, move it to the right, and then I rotate it like so, hit OK, and then just repeat the process. Okay. Okay, so I'm gonna do the first four, the four on the left side of my engine block. And again, we have to join the piston assemblies or the piston sub-assemblies into the cylinders and then into the crankshaft. Okay, so what I'll do here is I'm gonna rotate my view a little bit to make my life a little bit easier. And then what I need to do is I just need to add multiple joints between these. Okay, so again, I'll start off with joint. And what type of joint do we want? So if we look at the types, we have rigid. Rigid doesn't work in this case because I need the pistons to move. Revolute doesn't work because I need the pistons to slide up and down. And then we have slider and cylindrical, which both might work in this case. And then pin and slot, planer and ball. All the last three don't seem to do the trick for me. So I'm gonna try, so we've tried cylindrical before. We can try slider and see what happens, okay? So I'll go back to position, and then what I need to select is select the, okay, so select it again, there we go. I'll go ahead and select the surface, the cylindrical surfaces, and as you can see in this case, all it's doing, it's allowing that rotation, which is not exactly, oh, so it's back in Revolute. So let's try slider. There we go. So slider is allowing an up and down motion, but I don't know yet that I have the right angle for the piston rod to attach to the crankshaft. So even though I don't want this to rotate, I just want them to slide up and down, I might be inclined to just leave it as a cylindrical where it allows that rotation as well. And then that way I can adjust and set that rotation or limit that rotation later on. Okay, so again, in this case, I'm going to do a cylindrical, and I'm just doing the cylindrical surfaces of the piston rod to the cylinder. Okay, the piston head, sorry, the piston head to the cylinder. So I'll go ahead and select that one. That one's good. I'll go ahead and try the next one over. So there we go. It defaults to the cylindrical because that's the last one I used. So that's good. And just repeat the process a couple more times. There we go, joint. Okay, I'll come down. Okay, there we go. So I just position all four of the pistons here. Now what I want to do, and this is going to change a little bit from real life, I'm going to actually hide the engine block so I can see a little bit better what's going on the inside. Okay, so all I need to do is hit that eyeball for the engine block, and that's going to turn it off. I mean, it's still there, so the joints are still active. It's just hidden away from the view. Okay, and as you can see, all of those piston rods want to attach to the set of secondaries that are to the right. Okay, so it's going to attach there, it's going to attach there, it's going to attach there, and it's going to attach there. Okay, now what I'll do is I'll add the first joint, and then we'll see what happens. So I'll go ahead and add a joint. Now this joint between the piston rod and the secondary only has to be a revolute, so it should only allow a simple rotation. It shouldn't allow any movement. Okay, so for my type of joint, I already know that I'm going to try a revolute. Now I need to select the points of contact. So in this case, I'm going to go back to edge. So I'm going to limit that edge to the inside edge of this secondary. So what I'm going to do is I'm going to rotate this view a little bit, and then I'm going to select that inside edge of that secondary. And as you can see, it's giving me a warning because it's trying to shift. So I'm going to adjust that by going to motion and doing only a revolute. And now the warning goes away and it seems to work. Okay, now let's take a look at what happens as soon as I hit OK. Please take a closer look at the position of the crankshaft, and let's see what happens. So as you can see, I'll go ahead and do before, after. As you can see, the whole crankshaft shifts to the right a little bit. So as soon as I attach this piston rod to the crankshaft, then the crankshaft itself can no longer move left or right. The reason for that is if you do all the math and look at the angles, the only way that this piston rod can attach to this crankshaft at that particular secondary is by the crankshaft being at that specific spot. So if the crankshaft is not there, then we would have a conflict. Same thing goes for the piston rod. Okay, if we take a look at the other ones, these other ones can still rotate, right? Now this one here can no longer rotate, and it's also because of that. So that last joint limits both the crankshaft and the piston rod degrees of freedom that we were missing. Okay, so that's exactly what we want. So I'm gonna do Control Z to allow this one. Now, actually, I'm gonna rotate this a little bit like so, just to show you what I mean by that rotation, okay? So I'm gonna try the joint again. Yeah, capture the position, and I'm gonna select the edges again, okay? So this edge to the left has to come into contact with this edge on the left for my secondary. And as you can see, it attaches, it sort of does that rotation, showing me that it's good. And then if I hit OK, then you can see, now this is something that can happen. In this case, it exploded. Something weird happened, probably because of that angle. So what I can do is I can just Control Z that last joint and then try again. And this is one of the reasons why we tell you to sort of place everything pretty close to where it should go once you're done adding the joint. So it just wants to fall into place. If you allow Fusion to make crazy decisions for you, then it might do something crazy like what you just saw right now. So in this case, that's the joint. There we go. We fixed that. Control Z, try again, and now we're no longer having that issue. Okay, and then I'll go ahead and attach the other ones to the correct edges and continue forward. Okay, so the last one. I really have to zoom in for this one. There we go. Okay, so there it is. I have successfully attached the 4 piston assemblies on the left side of the engine assembly to the crankshaft. And if I rotate the crankshaft, we can see how those pistons are interacting now. Okay, now this is good. This is what I want to see. As you can see, if you remember when we first created the crankshaft, we talked about the order. This is why that order is important. We have the first and last going up while the two in the center go down, okay? And that's important because we need to keep a balance on the engine, okay? So I'll go ahead and continue forward by adding the other 4 piston assemblies on the other side, and then we'll talk a little bit more about how these things are joined and why they're joined that way. Okay, so I'll go ahead and start doing that. Now in this case, I'm going to move to the right. I'm going to adjust the angle a little bit, and then I'm just going to move it to the last position. Again, it doesn't have to be perfect. As long as we're pretty close, it should work. Okay, so there's one. I just repeat the process for the other ones. Now there's some shortcuts you can take here, like copy paste. I encourage you not to do those too often, because the crazier things you do, the higher chance of something messing up. Okay, so I suggest you just even if it takes a little bit longer, just do one by one, and then we can worry about that later. Okay. Okay, there's 3. and finally 4. There it is. Go ahead and click OK. Now, what I'll do here is just like I did previously, I'll attach all of the piston heads to the cylinders with that cylindrical constraint or joint. So I'll start it up, select that cylindrical surface, select that cylindrical surface. Again, if it shows up in blue, it's just asking for confirmation. Just click on it again. And notice how right now I have set it up for revolute. So I'll just switch from revolute to cylindrical. Now it's doing what I expect it to do. So that's good. And then just repeat the process. So joint first, select, and then hit OK. And then joint, select, hit OK. Joint, select, hit OK. All right. Now, just like I did previously, I'll go ahead and turn off the engine block so we can see what's going on inside. Now, all 4 of my pistons on the right side are now attached, but as you can see, they're trying to attach to the same secondary. Okay, that cannot happen, right? You're going body against body, and of course, in this case, it seems like the material is non-existent, so they can actually bind together. But in real life, that's not going to happen. So what needs to happen with all of these other piston rods is they need to be rotated 180 degrees, like so. Okay. The reason for that is now they're not going to attach to the secondary on the right. Now they're going to attach to the secondary on the left, which is what's free for them to use. Okay. So it's very important that you have all of the pistons on one side having the offset to the same side. Okay, so all of the pistons in the back here have the offset to the right, and then all of the pistons in the front have to have that offset to the left. Okay, so that's extremely important. So we'll go ahead and keep that in mind. And then of course I'm just going to position all of them pretty close to where they should be. Okay, just like that. Okay. Now, once that's done, then here we have a thing called position. Now, I haven't talked about this before because it's pretty easy to understand. But what's asking us to do is, hey, you want to capture the current position, so the new position that you just adjusted, or do you want to revert to the previous one? Now, the reason for this is Fusion actually sort of keeps track of the location and orientation of each component within the environment. So if you move something, it's asking you to select whether you want to keep that new information for the new position and orientation, or if you want to keep the last one. So it's very important that if you adjust something, you always hit capture position, and then that way you don't get that message when you start trying to add the joint. Okay, so again, it's very important you do those things, so just keep that in mind. Okay, now that we have positioned everything in such a way that it just wants to fall into place, then what I'm going to do is I'm going to actually attach them together just like I did the other side. So again, we're going edge to edge here because they're going to be revolute. Okay, so as you can see, it's back at cylindrical because that's the previous one we used. So all I need to do is go to motion and select revolute instead. And then I'll go ahead and click OK. So that's the first one down. I just have the 3 last ones to go. Okay, so there it is. And there it is. Okay. Now, what I'm going to do here is I'm going to mess up in purpose. That way you can see what happens or what to expect in case you make a mistake. So I selected the edge here towards the left. And what I'm going to do is I'm going to select the edge of the secondary towards the right. So we know that cannot happen, right? It's going to sort of bind body on body. But let's see what happens. So in this case, the animation tries to do it, but it's giving me a warning. It's telling me the selected joint will result in a conflict. And of course, it's going to show up in red and it's not going to allow me to do anything. The reason for that is in order for that joint to actually happen, we would have to have this piston head shift to the right by exactly the length of that secondary, which is 4 millimeters. And of course that cannot happen because that's already set. So the only way that this can attach is if this edge and this inside edge of the secondary are the ones that are coming into contact. Okay, so again, just sort of expect to see mistakes like that happen, but understand how to fix them. Okay, and then I undid a lot of things. I went way too far. Okay, so let's try that again. Joint this edge to this edge. Hit OK. Now here we have this one that sort of went crazy on me. So I can do a Control Z and then try to rotate, make some change to where it doesn't explode like that. Okay. Again, sometimes things like that happen. So again, capture the position. You can just Control Z and try again. Okay. So let me try that again. There we go. There we go. Hit OK. And that works. Okay. So that's the first one down. I'll repeat the process for the other three. So there's the second one. Again, all my pistons are in the right orientation, so that's good. There's the third. Okay, and then finally the last one. Okay, seems like everything's working out fine. So now each of the piston rods have their location correctly set to their corresponding secondaries. And as you can see here, all of the pistons here have the offset to the left, while the pistons on the other side have the offset to the right. So that seems to work. Okay. Now all I need to do now is turn the engine block back on, and if I test this, then I can see how everything's working out. Okay. Now it's very important to realize what the offsets did and why the order for the crankshaft was important. So as you can see in this position, I have the two outside on the right and the two inside on the left going up, while the other ones are going down. That means that in essence, I'm going to have the same force acting up on the left as I have acting up on the right. Okay, and that happens at any given point in time. So what this allows is for an engine that's actually balanced. Otherwise, if I were to have all of the pistons on the left go up at the same time and all of the pistons on the right go down at the same time, then the forces acting on the engine would make my engine rock back and forth because it's unbalanced, right? So it now keeps a lot of force on the right, and then it keeps a lot of force on the left, and eventually it's gonna once you start hitting the gas and this thing's accelerating, then those forces will probably break everything in your engine bay. You'll destroy the engine mounts, and you'll probably have your engine running away from your car, which is not good. Okay, so again, there's a reason why we always try to balance things out, especially in machines that are in motion most of the time. So in this case, we try to have a balanced engine so we don't have any rocking back and forth. That way everything stays in place. Okay, now finally, the only thing left to do here is I'm just going to turn off all of the joints that I can see here, just because they look very messy. Okay, so what I'll do is I'll look for joints, turn them off, and even though the joints are still there, they're no longer visible. Okay, and all I need to do is save this file. Now, like the way I showed you in drafting, any changes you make here will or can be updated into an assembly. So if you modify one of the original components, then you can actually update the assembly, so you don't have to do a whole assembly from scratch. That being said, you have to be very careful as far as what type of adjustments you make, because if you make an adjustment that's too big for Fusion to understand, then some of the joints you already created might come into conflict, and then you're gonna have to go back and modify those to no longer be in conflict. Okay, so just sort of keep that in mind. Now, I'll go ahead and stop this video here. Hopefully everyone understands what's going on. We tried, I believe, like 2 different types of joints. I'm going to try to give you more examples for more joints in the coming videos. So just make sure you're looking at Blackboard for that. And then if you have any questions about assembly so far, you can always shoot me an email. If you just want to rewatch this video, you can pause play as many times as you need. So you're free to do that. Okay. So I'll go ahead and stop the video here.